So now the third point is the electric field due to electric field you have to find on the axis of circular uniform charged ring, uniformly charged ring, right? What does it mean? If suppose this is the ring and this is the axis, right? This is the plus charge on the circumference. Is it clear? So this is the Q and this is what? The axis. Is it fine? So at this point from the center of the axis, right, you have to find the electric field at this point. Suppose the radius is to be the R. Is it clear? So at this point you have to find the electric field and the charge is distributed uniformly over the circumference of the ring, right? First copy this and think how to solve this. So we can do how to solve this. Listen one thing. To solve this, you will assume this is the dq charge, right? This is the elemental dq charge, and because of this elemental dq charge, this is supposed to be R, this is X, this is small r. Because of this elemental charge, the electric field is dE, right? What is the value of the dE? It is k dq upon r square, right? We cannot write the electric field due to all the ring, but because of this small elemental charge, at least we can write the small elemental electric field k dq upon r square. Fine, this is the dE. So listen one thing, if you assume this is the theta, this is also theta, right? The component is d cos theta, d sin theta. Listen one thing, just opposite to this, if you consider the similar elemental charge dq, right, and because of this elemental charge, the dE will be also there, right? It is dE if it is theta. Listen one thing, if you consider this the dE, the component in this direction is dE sin theta, the component of this dE, if it is theta, so this is also the dE sin theta. It means these two sin theta will cancel each other. Is it clear or not, you tell? Right. So in the same way, if you consider the any element, any small portion, the if for this small portion in opposite direction, the d sin theta component will cancel out. For this and this small elemental charge, the d sin theta component will cancel out. So the dE sin theta component will cancelling each other, and what are adding? The cos component are adding. So if at this point the net electric field will be in this direction, and this electric field is nothing but the summation of all cos component, d cos theta, d cos theta, d cos theta, due to each elemental charge dq, the summation of dE cos theta will give the net electric field. The summation is nothing but the integration d cos theta. You understand or not? Right. So all the cos component of the dE will be added to give the net electric field over there, right? And what is the value of the dE? You tell the dE is nothing but k dq upon r square into cos theta. What is r? This r is nothing but root over r square plus x square. So I will write k upon r square plus x square dq into cos theta, right? What is the cos theta? You tell. If this is x, this is r, this is cos theta is nothing but base upon hypotenuse. So the hypotenuse is nothing but root over r square plus x square is the cos theta, right? So this is nothing but k r square plus x square. The cos theta value I am writing this x upon root over r square plus x square into dq. So you will write this is the kx, right? In the denominator you may write r square plus x square raised to the power 3/2 into dq, right? Copy this first. Listen one thing, now you have to integrate. How to integrate? Listen one thing, if you consider this is the r is constant and this is the fixed distance from the center to this point P on the axis. So r and x are constant. So therefore kx r square plus x square raised to the power 3 by 2 is also constant. So it will come out from the integration. So kx upon r square plus x square raised to the power 3 by 2 and integration of dq. So if it is dq and the total charge on the ring is q, so the integration of dq is nothing but capital Q. So this is nothing but kx upon r square plus x square raised to the power 3 by 2 into capital Q. So kqx upon r square plus x square raised to the power 3 by 2. Is it clear or not? So this is the electric field. Is it clear? So this electric field is a function of x. Find the electric field, although you tell me at x is equal to 0, x is equal to 0. What is the electric field? Definitely on the center, because of this uniformly charged ring, the electric field on the center will be 0 if you put x is equal to 0 over here, right? At x tending to infinity, if the infinity mean at very large distance, if this is the ring, here it is the ring, and you want to find the electric field at the infinite distance, right? When you will simplify it with the help of the limits in the mathematics, so again the electric field will be 0, right? So here I am going to make the graph of this function. You must remember also, right? If this is the plus q charge distributed over the circumference of the ring, right, the graph of the electric field at this x is equal to 0, the electric field is 0. At the infinity, at very far away from this, the electric field is also again 0. Is it clear or not? So this graph is like this. The electric field, right, is like this. This is the graph of the electric field. Is it clear or not? So at somewhere the electric field will be maximum. At center the electric field is what? 0. Then it increases, and at this point, at some point, the electric field become maximum, right? It is the maximum electric field. Then when you increase the distance, the electric field reduces and become infinity. At infinity it becomes 0. In this direction, the electric field is in this direction like this. This is the maximum electric field, is this point, right? This is the maximum electric field. This is the maximum electric field. All right, fine. This is the maximum electric field here. In this case, the electric field here, and the direction is just opposite. So if you want to make the graph, the graph is like this, right? This is the maximum electric field in this case, right? Although this value of the x is I think r by root 2, right? I will explain how does this value comes, right? So this is the electric field as a function of x. At center it is 0. It is continuously increasing. At x is equal to root r by root 2, it become maximum, then decreasing. So this is the graph of the electric field as a function of x, right? Copy this. So first you will remember this formula. Also, this is the function. The graph is like this. This function appears many times, not in this chapter, in the mathematics also, anywhere it can come. So you have to find if this is the electric field as a function of x, right? So can you find at which distance, at which value of x the electric field is maximum, right? To find the maximum value, this is the electric field as a function of x, kqx upon r square plus x square raised to the power 3 by 2. This function as a function of x may be written as x into r square plus x square raised to the power minus 3 by 2, right? Now you want to find its maximum value, right? So to maximize this, you have to differentiate, that is dE upon dx. If you assume this is to be x, then you have to differentiate. The kq is the constant. Assume this is the first and the second function. So first function as it is, you are differentiating this, right? First function as it is, differentiation of second, n x ki power n minus 1, right? Like this. This is minus 1 like this into differentiation by chain rule 0 plus 2x plus the second function as it is. This is the second function into the differentiation of first function. The differentiation of x is 1. Is it clear? So the kq, simplify this, it become minus 3x by 2, right? This is the 2x multiply by 2x and it become r square plus x square raised to the power minus 5 by 2 plus it become r square plus x square raised to the power minus 3 by 2. Is it clear or not? So if you take common minus 3, this is kq. What is the common? Right, the common is r square plus x square raised to the power minus 3 by 2 if you take common. So here it is minus 3x square. If minus 3 by 2 is common, r square plus x square minus 1 plus 1 will be there. Is it clear or not, you tell? Right. So this is equal to kq, r square plus x square minus 3 by 2. This is 3x square divided by r square plus x square plus 1. Right. This is the dE upon dx. Right. This is the kq. To find the maximum value, you have to find the dE upon dx. You want to maximize this function and put it equal to 0. So when you will put it equal to 0, you can find the value of the x upon r square plus x square plus 1. When it is 0, this come in denominator, only this is left, minus 3x square upon r square plus x square plus 1. Right. If you simplify this, this is the minus 1 is equal to minus 3x square upon r square plus x square. Right. Minus minus will cancel out. R square plus x square is equal to 3x square is equal to what? 2x square. X square is equal to r square upon 2. X is equal to plus minus r by root 2. Plus minus r by root 2 mean from center to this distance, this is plus r by 2 and this is x is equal to minus r by root 2. So these are the position where the electric field is what? Maximum. Right. So this is plus r by root 2 is the distance from the center where the electric field is maximum. Then it is decreasing. At the center it is 0, then first it is increasing, then it is decreasing. Right. Copy this. Listen one thing. For example, how they will ask the question. Suppose this is the uniformly charged ring and the charge is what? It is q. Right. Over here the distance is r root 3. You have to write the electric field. Right. The radius of this ring is assumed to be r and the distance r root 3 on the axis. You want to write the electric field. Directly formula you will remember kqx upon r square plus x square raised to the power 3 by 2. So put just x is equal to 1. X is equal to what? X is equal to r root 3. So r root 3 is equal to what? Kq r root 3 divided by r square plus, right, r root 3 whole square. Right. It is 3 by 2. So this is kq r root 3 divided by, this is how much? R square plus 3r square is equal to 3 by 2. This is equal to what? kqr root 3 divided by 2r. This is 4r square, right? Raised to the power 3 by 2. So what will you write? kqr, when you will simplify it is 3 by 2, mean 4r square root over 4r square, right? Or whatever you want, 2r ka whole square. It may be written as raised to the power 3 by 2. It is cancel out. So 2r raised to the power 3 is equal to 8r cube. So I am writing here 8r cube. So it may be written as kq root 3 upon 8r square is the electric field, right, at this point. That's it. So in this way, although we have done this derivation, but you have to remember this formula, right? Directly we are going to use this formula to solve the questions, right? You have to remember. Copy this. So the next is the electric field you have to find due to uniformly charged disk. Uniformly charged disk, right? Uniformly charged disk or disk, DISC, you can write. Uniformly charged disk means, suppose in the previous case it was ring, now on this disk the charge is uniformly distributed over the surface, right? Like this, like this, like this. Is it clear? Total charge is Q over there, the radius of disk is R, and you want to write the electric field as a function of x on the axis due to this uniformly charged disk. You understand the question? The previous case, the charge was distributed over the circumference of the ring. Here the charge is distributed over the surface area of the disk, and this is the point on the axis. You have to write, or you have to find the electrostatic field, right? Do you understand the question? First copy this, think about this, then I will explain. So how to find the electric field? We don't know, or we cannot write the electric field due to all this charge, but at least we know the electric field due to the ring. So for that case, in this case, at distance r, right, at distance r, you will assume the elemental ring of the width dr. So if this is the elemental ring and the width ring is dr, and here the charge in this elemental ring is what? Say dq. Dq is the charge, dr is the width. So can you write the electric field due to elemental ring at distance x? Yes. The electric field, the elemental electric field due to this elemental ring is, right, k dqx upon r square plus x square raised to the power 3/2. You understand or not, you tell, right? R is the radius of this ring. Do you understand this thing? Kqx upon r square plus x square raised to the 3/2. Now to find the net electric field at this point, right, because of this elemental ring, the electric field dE we have written. Fine. Now you have to integrate this, because this is the one elemental ring, and to find the net electric field you have to integrate this dE, right? K dqx upon small r square plus x square raised to the power 3/2, right? Because there will be so many rings. This is the ring, this is the ring, this is the ring. So the r will varies from r is equal to 0 to capital R, right? This is the capital R. So these elemental rings start from r is equal to 0, and they are extended up to what distance? Up to capital R distance, right? So you have to integrate this, but the same problem is there inside this. Listen one thing, this is the x is constant, the variable is small r. So here the small r is the variable and this dq is the variable. So you have to write down the dq in terms of, right, in terms of q and r. So how would you write? We will use the unitary method. How? If the charge is distributed over area, so what is the total area? Say pi r square. On pi r square, what is the charge? Say q. So for 1 meter square, what is the charge? Q upon pi r square. This is nothing but coulomb per meter square, and this is the surface charge density. Also you can say sigma coulomb per meter square, right? Listen one thing, this is the area pi r square, the charge is q. For 1 meter square, this is the q upon pi r square. So what is this dq charge, right? If you cut this ring, and stretch this like this, so the width of the ring is what? dr. Fine. And what is the total length? Say 2 pi r. So what is the total area of this strip? The total area is 2 pi r. 2 pi r is the length and the width is dr, right? So for pi r square, the charge is q. For 1 meter square, the charge is this. So in this strip of the width dr, the area is this, so in this area, right, so therefore in 2 pi r dr the charge will be q upon pi r square into 2 pi r dr, and this is nothing but dq, right, pi will cancel out, 2kq upon r dr upon r square. This is the elemental charge dq in this small strip or the ring, right. Copy this first, then we will put the value of the dq over here and then we will integrate, right. Copy this. Any doubt you can ask, right. So here the calculation may be little long, right. The k into dq, the dq is 2q r dr upon r square divided by r square plus x square raised to the power 3 by 2, fine, into x. I think you are getting this thing. So 2kq upon r square into r into x into dr upon r square plus x square raised to the power 3 by 2. The x will also come outside, 2kq upon r square into x, and inside it is r root over r square plus x square raised to the power 3 by 2. Is it clear or not, Yuta? Right. So now this the x is constant first of all, only the r is variable, right. One more thing, how to integrate this? How to integrate? Tell me. The small r is 0 to capital R, right. The r varies from 0 to the small ring extended from 0 to capital R. So how to solve this? Listen, the method is called the substitution method, or some, do you know the substitution method of the integration? I think you don't know, but we can do in this way. Suppose this is the angle alpha, right. So what is the tan alpha? Tan alpha is nothing but r and this distance is x. So here the alpha is variable like this. The x is constant is r is equal to x tan alpha. Fine. So if you differentiate this dr, the x is constant, it is sec square alpha d alpha, right. So I am converting the variable from dr to alpha. Here you can write in this way, 2kqx upon r square, right. The r value is what? The r value I am writing x tan alpha, fine, divided by r square. R value is what? X square tan square alpha plus x square raised to the power 3 by 2, and the dr value is the x into sec square alpha d alpha. This is equal to 2kq upon r square into x, fine. This is x into x, this is the x square, this is tan alpha sec square alpha, this is the d alpha, divided by, listen one thing, the x square if you take common, the tan square alpha plus 1, and it may be written as x square into sec square alpha. So in the denominator it is x square sec square alpha, right, raised to the power 3 by 2. First copy this first. If any doubt you can ask, right. R, we are converting the variable r into the alpha, because alpha is also variable. As the r is changing, the alpha is changing, right. Although there may be the another method to simplify this integration, and the integration is taught in the class 12. So I am, therefore the many methods are there, I am using one, the substitution method, right. Copy this. So this x square come out from the integration, it become x cube, right. Here the tan alpha and this is the sec square alpha divided by, this is what? the 2 will cancel out, so x sec alpha raised to the power cube d alpha, right? So it become what? 2kq upon r square x cube tan alpha sec square alpha upon x cube into sec cube alpha d alpha. The x cube will cancel out, 2kq upon r square, right? And this is the tan alpha, may be written as sin alpha upon cos alpha. Listen one thing, it is cancel out, so this is the sec alpha d alpha. Is it clear or not? So this cos alpha and sec alpha is cancel out. Inside the integration, this is the sin alpha d alpha, right? So what is the integration of the sin alpha? You can tell me, right? I am deleting everything right here. Tell me, this is nothing but equal to 2kq upon r square. The integration is minus cos alpha. Is it clear or not? And what is the cos alpha here? You tell. The cos alpha is nothing but base upon hypotenuse, right? Root over r square plus x square. Is it clear? So I'm writing this side. So the electric field is 2kq upon r square, 2kq upon r square minus x upon root over r square plus x square. And the limit varies r. Now it comes in the variable r. The small r varies from 0 to capital R. From 0 to capital R. Is it clear or not, Uter? Right. So, give me 1 minute. Sin alpha is equal to, sin alpha and cos alpha is equal to x. So now you put 2kq, I am writing this side, 2kq upon r square, right, minus x upon, in terms of, in place of r square plus x square, minus, right, and the minus x upon 0 plus x square. Fine. So it is equal to 2kq upon r square minus x upon root over r square plus x square. Minus minus become plus, x upon x become 1. Is it clear or not? So it is 2kq upon r square 1 minus x upon root over r square plus x square is the electric field as a function of x on the right, on the axis of the disk, right? You have to remember this. The easiest way I will tell you, first copy this. Let's see the simplest way. Although this is the derivation for the advanced, you must understand each and everything, but finally to solve the JEE Main's question directly, we have to use the formula, right? So what will you write? If this is the disk and on this disk the charge q is distributed over the surface area uniformly, the radius is assumed to be the capital R, at distance x, the electric field is 2kq. The electric field is 2kq upon r square 1 minus x upon root over r square plus x square. Is it clear or not, Utal? Right. Although I have assumed this angle is alpha, which is variable, but if you consider the final angle which is constant, this is theta, and if this is r, so this is root over r square plus x square. So what will you write? The cos theta is what? Say x upon root over r square plus x square. So therefore this term may be replaced by 2kq upon r square, 2kq upon r square 1 minus cos theta. Now it may be remember little easier way. Is it clear or not? Another form, sometimes they don't give the charge, rather they will give the surface charge density, the sigma, right? Sigma coulomb per meter, this is called the surface charge density they have given, and the radius of the disk is r. You have to write the electric field at this point. Is it clear or not, Utal? So if the surface charge density is sigma, that is q upon what? Pi r square. So this q may be written as sigma into pi r square. So here I am going to replace the q by sigma into pi r square upon r square, right? And this is the k. What is the value of the k? K is nothing but 1 upon 4 pi epsilon naught. This is the q. This is the r square 1 minus cos theta. Now it become more simpler. Pi r square is cancelled out, 2 upon sigma naught 1 minus cos theta. So this is the electric field, right? This is the electric field at this point is nothing but sigma upon 2 epsilon naught 1 minus cos theta in terms of surface charge density. Is it clear or not? Right, copy this. So now we are discussing the electric field due to the state line charge, line charge, uniformly linear charge density, and due to the circular arc. Right, I'm just revising the thing. Due to the circular arc, what is the electric field util? If the linear charge density is lambda coulomb per meter, and this angle is alpha and this angle is alpha, the electric field here is nothing but 2k lambda upon r. R is the radius into sine alpha. Is it clear or not? Like this, 2k r, 2k lambda upon r sine alpha, or if it is written in terms of q, it may be written as kq upon r square sine alpha upon alpha, right, in terms of q. Is it clear or not? Right. For example, for quarter circle, for quarter circular arc, what is the meaning of the quarter? The quarter mean the 1/4, right? If this angle is 90 degree, is it clear or not? And this is the charge, right? So what will be the electrostatic field over here? If this is the 90 degree, this is the quarter circular arc, right? Quarter mean the 1/4 I am talking, like this. So this all angle is 90 degree. So half angle is 45, half angle is 45 degree, right? So this is the 45 degree. This is also the 45. So what is the electric field util? It is equal to k lambda. I am writing 2k lambda, right? 2k lambda upon r into sine 45. Sine 45 is what? Say root 1 by root 2. 2k lambda upon r into 1 by root 2 is equal to root 2k lambda upon r. Is it clear or not? In terms of lambda it is, right? In terms of E, in terms of q, you may also write. For example, listen one thing. If this is the quarter circular arc like this is the quarter circular arc. Fine. Not the semicircle. So what does it mean? Util. The electric field due to this circular arc, whether you put this circular arc in the symmetric or in this way, so the electric field will be here. This is 45 degree and this is also the 45 degree, right? If you assume the lambda coulomb per meter is the 45 degree, lambda coulomb per meter is the linear charge density. So what is the electric field? You will say electric field is 2k lambda upon r sine 45. So it is nothing but root 2k lambda upon r. Is it clear or not, util? Right. For example, listen one more thing. If the charge distribution is like this, on the half of the on the 1/4 circle, this is positive charge, that is plus lambda coulomb per meter, you may write. Here it is what? Say minus lambda coulomb per meter is the linear charge density. So what is the electric field at this point O? How would you write? So listen one thing. This is the quarter. Because of the quarter circle, because of this quarter part, the electric field will be E in this direction. The value of the E is definitely this. But if it is negative, suppose, right? If this is the positive, the electric field is away. But if the charge is negative, what will happen? Util. The electric field will be the same value, right? It is 45. It is also 45. The electric field value will be the same. It is equal to root 2 k lambda upon r, but the direction will be just opposite. So if you consider this is the negative linear charge density distribution, so the electric field will be in this direction, and this is equal to E. Is it clear or not? So if this is 45, this is 45, so this is 45 degree, it means it is 45 degree, this is 45 degree. Are you getting or not? So what is the resultant electric field at this point? If this is E, this is what? This is the E sine 45. The value of E is this, and the component of this is what? Say E sine 45. Right. So sine component will cancel each other. Right. Only this is the 2E cos 45. So the resultant electric field at this point is nothing but, right, it is 2E cos 45 1 by root 2 is equal to root 2 into E. And what is the E value? You tell. The E value is nothing but, this is the E value, root 2 k lambda upon r. So this is equal to 2 k lambda upon r, and the net electric field will be in this direction. Is it clear or not? So with the help of this formula, either you can use, when the linear charge density is lambda is given, you can use this. If the Q is given, you can use this, right? So you can find the net electric field in this case, right? Copy this. For example, one more illustration we can do. For example, this is the semi-infinite line charge over there, right? And this is the semi-infinite line charge having the lambda coulomb per meter. Now it turns into the semicircular arc. Fine, like this. The radius of this semicircular arc is to be r, and this is what? Say infinite. Again semi-infinite, right? This is the point. The linear charge density is lambda coulomb per meter. So you have to find the electric field at this point, right? This is the C or the O, you can write. Find the electric field, right, at O, as shown in figure. As shown in figure, right? This is the question, right? First copy this, think about this. How can we do? This is the one part, this is the one part, this is the another part. The electric field formula directly you have to use to find the net electric field at this point, right? Copy this and think. So how to solve this question? Let's see. Listen one thing. First of all, if you consider only the semicircular arc, please tell. If the linear charge density is lambda coulomb per meter, it is similar. So if this is the lambda coulomb per meter, because of this semicircular arc, right, the electric field at this point will be what? Tell me. What is the formula, Varsha? Anyone, can you tell? Yes, Varsha. Anyone? What is the semicircular arc electric field at the center? Very good. 2k lambda upon r. So we know this. We have derived. We are using directly the formula. Listen, one more thing. If you consider the semi-infinite, yeah, you can check your note. If this is the distance r and this is the semi-infinite portion, so at this point, the two electric field was there in this direction, in this direction. Can you tell me what is the magnitude of this component and what is the magnitude of this component? K lambda by d, and k lambda by r, and k lambda by r. Very good, very good. Right, so you remember this, and the magnitude also we can write k lambda upon r root 2. So first draw the first part. You can divide all this structure in the three part: first part, second part, and the third part. First is the semi-infinite part, like this, like this, like this, like this. Is it clear or not? You tell. the lambda coulomb per meter. Because of this, at distance r, because of this semi-infinite portion, the electric field is k lambda by r in this side and the k lambda by r in this side. Is it clear or not, you tell? And in this way, in the same way, if you consider the another semi-infinite parts, right, this is the semi-infinite parts, getting? So because of this semi-infinite parts, the k lambda upon r this side, right, and k lambda upon r this side. Are you getting? So it become 2k lambda, I am writing in this way, k lambda IR, k lambda upon r, k lambda upon r plus. Is it clear or not? You may write in this way. So this k lambda upon r and k lambda upon r will cancel out. So because of this, these two straight line, first and second, right, the net electric field is in this direction and it is equal to what? Say 2k lambda. Is it clear or not? But if you consider the semicircular charge like this, are you getting? And because of this semicircular arc, the electric field is in this direction. And how much it is? Say 2k lambda upon r. So you tell, if you consider this is the point P, O, so because of this semicircular arc, the 2k lambda upon r is in upward direction. And because of this portion, the electric field is, right, this portion, this cancel out. So it is what? It is 2k lambda upon r in the downward direction. So what is the net electric field at O? Say 2k lambda upon r minus 2k lambda upon r, it is 0. So the electric field at this point is 0. Are you getting or not, you tell? Right. So in this way, if you know the formula, right, x-axis, y-axis component due to the semicircular arc, then you are able to find the electric field at this point. This type of the question is asked in the JEE Advanced, right? Copy this.